Hello दोस्तों, today in this video I am going to talk about PG semester 3 bioorganic chemistry topic like enolic intermediates, isomerization and rearrangement reactions. So every person know the isomerizations and rearrangement because in early classes you have the syllabus on this topic. Here how you will write on this topic: isomerization and rearrangement reaction. You know these reactions play important part in metabolism because this syllabus belongs to bioorganic chemistry. Definitely bioterm will be beneficial for us. So, metabolism phenomena. Isomerism is the reaction in which one isomer is changed to another. In biochemical reaction, this transformation takes place in two ways. First way, by change of position of double bond with the intermolecular change in the position of two hydrogen atom. And aldose ketose isomerism is an important example of intermolecular shifting of hydrogen atom. For example, interconversion of dihydroxyacetone phosphate into diglyceraldehyde 3-phosphate. This interconversion takes place in the presence of triphosphate isomerase. This is the one enzyme. Similarly, the reversible reaction which takes place in the presence of glucose phosphate isomerase, you can see this is the example: dihydroxyacetone phosphate. Here glyceraldehyde 3-phosphate. So fructose 6-phosphate converted into glucose 6-phosphate. So in this reaction, enediol is the intermediate compound. Now here little bit not very visible, but try to understand. Here the OH, so H plus, and the meanwhile the breaking of this bond, so base, here this base, now the formations of OH BH here, and this is the OH bond, this is the enediol H B, and this is the CONH. So after this cyclizations, you have the 1, 2, 3, 4, 5 member ring, including carbon OH, here H, and this is the base taken by, so the formation of this cyclized sugar. So this reaction involves conversion of C1 carbonyl group of glucose into C2 carbonyl group of fructose. In the next step, OH group attached to carbon 1 of fructose is easily phosphorylized to give 1,6-diphosphate. Now, intermolecular rearrangement of functional group is comparatively less frequent in metabolic process. However, in the metabolism of glucose, conversion of beta-D glucose 6-phosphate into beta-D glucose 1-phosphate in presence of phosphoglucomerase is an important example of phenomenon. In this isomerization reaction, phosphate group present on carbon 6 is shifted to carbon 1. You can see here this CH2O phosphate containing beta-D glucose biphosphate. After phosphoglucomutase, this is the enzyme. You can see here the formations of this OH is converted to this one, and this phosphate converted into CH2H. So beta-D glucose 1-phosphate. Now, pentose phosphate also shows different types of isomerization. You have CH2S, CO, HOH, HOA, CH2O phosphate, 5-ribulose, ribulose 5-phosphate, and in presence of phosphoglucomutase enzyme, epimerization occurs and formation of these products. So, the epimerase enzyme making change in the arrangement at the carbon 3 gives the epimer. Hence, the process is known as epimerization, a special type of. You have already read this one in Gavations in carbohydrate chapter. So ribulose 5-phosphate, ribulose 5-phosphate ketoisomerase, this is enzyme. You will get this indiol and it undergo shifting and give ribose 5-phosphate. So this reaction is keto is converted into aldose.